Hello everyone, welcome back to our channel. This is lecture series 5 dealing with NoSQL Graph and Hierarchical Databases. Moving on to the deepest part of NoSQL, these are the fundamental types of databases which you have already seen in the other data series. Now we will be moving on into NoSQL database. What is NoSQL database? It is nothing but it is a non-relational databases which is used to store the data in a non-tabular form. That is, it consists of semi-structured and unstructured data. It doesn't have structured data. It doesn't follow any structured procedure to store the data. It is either semi-structured or unstructured data. And it consists of some types in it. That is document-based databases, key value stores, column-oriented database, and then graph-based databases. So moving on to document-based databases, this is nothing but it is a non-relationship database. What it does is, instead of storing the data in terms of rows and columns, it is using the format of document to store the data in the databases. So it uses either PDF form or docx, any kind of document form. So in document databases, there are some particular elements that can be accessed by using a value which you call it as index value. So that will be assigned for faster querying. You can just put the index value in the document so that the data content in the document will be taken. Next is key value store. This is also a non-relationship data, that is non-relational databases. So this is the simplest form of NoSQL databases, which we call it as key value store. So here every data element in the database will be stored in this key value pairs. You can see you have a key and a value. So this you call it as key value pair. So these values are nothing but it is a simple data type, like it can be a number, it can be a string, or it can be a complex objects also. Here the data can be retrieved by using a unique key allotted for each element. So the first key pair having any number or any object, it will be assigned with a unique key, and with that unique key querying can be done so that each element can be accessed from the database. Next is column family database, that we call it as column oriented database. This is also a non-relational databases. Here it stores the data in columns. It doesn't use rows. That is why you call it as column family. Here the column databases, it is designed to read the data efficiently, and so that it can be retrieved at a faster rate, faster speed, because you don't have rows, you just have only columns, so easily you can pinpoint the data in the column database. Next is graph database. So graph database, it is a database which is using graph structure for storing the data, and it uses nodes, edges and properties instead of tables, or it doesn't use documents to represent or store the data. So now in detail we will be seeing about graph database. So we have seen that it uses a graph structure. So you can see it is using a graph structure where you have vertices and edges. So this is a typical example for graph database. So moving on in detail how graph database works, you can see these are 5 friends having relationship with each other, right? The friend 1 is connected with friend 2, it is connected with friend 3, it is connected to the other friend. So you can see each and every friends are connected to each other friends. So totally 5 which is connected to each other. So this one friend is connected to all other 4 friends. This friend is connected to all other 4 friends. So this forms a tree. It forms a graph. You can see a graphical representation between each friends. So now when you take a particular friend, Chaitanya, okay, so this Chaitanya is having a relationship between all the other 4 friends. So now you are providing the ID for other friends. So say suppose this is the third friend. So user ID will be 3. Now this user ID 3, that is friend number 3, is having relationship with 1, 2, 4 and 5. So other 4 are interconnected. So by this graphical representation, you can easily make out who is connected where. So it forms nodes, edges, vertices. That is why you call it as graph database. Now moving on to the next one, it is nothing but hierarchical database. So this is hierarchical database. Here the database model is used for modeling the entities in such a way that one child entity can have more than one parent entity. That is, see, this is the parent entity, university is having two child, that is department and administration. Now it doesn't stop here. The hierarchy keeps on growing. The department can further be divided into, so the department now acts as a parent which divides into three child pattern: student, faculty and resources. Again, administration can be a parental node and it can be divided into a number of child node. So this is nothing but developing of hierarchy databases or representing a content in a form of hierarchy. So here you can see that not always, but maximum situation, maximum times the network model works best in this model, that is hierarchy database. It is going to support many and many relationship, as you see here. It is just not stopping with number of students, faculties, resources. Under students there are types of students: weak learners, quick learners. It can be achievers, toppers, faculty. Under faculty there are a number of faculty, grades, right? And these entities will be represented as a connected network with each other. That is what. So it is connected to a one node where it forms branches. So one child entity, maybe I take this as a child entity now, it can have more than one parent entity also. It doesn't mean that it can only depend on university. It can also depend on any other type of parent. It can be office having a number of departments. Yes, so it can be represented in form of network where one child will have more than one parent, and these entities will have multiple parent entities and it will lead to complex structure. It is actually easy for representing the data because it is tree-like structure. It forms a tree-like structure. Data can be easily taken via links, but it is not very flexible because you cannot reorganize the model. Once organized, yes, the database is ready, but reorganizing the data is not that flexible. So the performance of network data model keep varying depending upon the use case or depending upon the complexity of a relationship, and based on that the performance of the databases will be accounted. Hope you have understood these three databases. We'll be seeing another three databases information in the next video. Please be stay tuned. Thank you.